Hi everyone, welcome back to my session. This is E. Manjula, lecturer in Electrical and Electronic Engineering, Government Institute of Electronics. Today we will discuss about the RMS and average value and the problem on it. In a previous session, we have discussed about the various definitions which are related to the alternating quantity, alternating quantities, and we have solved some simple problems also. In this session, we are going to calculate the average and RMS value by mid-ordinate method. So what is an average value? Average value we have already discussed its definition. Once again we will check it. Okay, we will see. The average value of an alternating quantity is a steady is the steady quantity flowing through the circuit which transfers same amount of charge as that of the alternating quantity. So root means square value. What is the root mean square value? The RMS value of an alternating quantity is the steady quantity flowing through the circuit produces the same heating effect as that of the alternating quantity. So there are the methods of calculating RMS and average value of an alternating quantity. The first method is mid-ordinate method and the second one is analytical method. In this session, we will see the mid-ordinate method. So here, say this is an half alternating quantity, positive half wave. Okay. So here what we are doing, we are dividing the wave in time base t into an equal intervals of time, and each time period is t by n seconds. With equal intervals, we are dividing the alternating quantity. That here it is a current. Okay. So let the magnitude of instantaneous currents be I1, I2, I3 till In. So here we know that this in y-axis there is current and here in x-axis it is t. So we are taking each and every magnitude of an alternating quantity, that is the current, as we are taking n intervals. So n number of I magnitudes will be assumed, and considering that I1, I2, I3, In at a regular intervals of time, and the average value of an alternating quantity is given by I average is equals to I1, I2, I3, I1 plus I2 plus so and so till In divided by n. So this is an I average. So considering the following diagram, the same diagram as an average, what we have did, that we have divided the time base t into the equal intervals of time, and each of the time duration is t by n seconds. So here, let the magnitude of instantaneous current be I1, I2, I3, so on till In at the regular intervals of time. So let capital I be the alternating current passing through a resistance of R ohms. Then heat produced in first interval is equals to 0.24 I1 square R T by N. So here 0.24 factor has come only due to the R AC and R DC. Okay. So second interval is equals to 0.24 I2 square R T by N, and third interval which is equals to 0.24 I3 square R T by N calories. So likewise till nth interval which is equals to 0.24 In square RT by N calories. So The total heat produced in T seconds is capital H. So what is that? Capital H is equals to 0.24 RT into I1 square plus I2 square plus I3 square, so on till In square divided by N. So say this is an equation 1. Suppose a direct current of value capital I produced the same heat through the same resistance during the same time, then the heat produced I is equals to 0.24 I square RT calories. So this is for DC and this is for AC. Okay. So by the definition that the two amounts of heat produced shown in equation 1 and equation 2 are equal according to the RMS definition. Okay. So here equation 1 is equals to equation 2. So that is 0.24 I square RT is equals to 0.24 RT into I1 square plus I2 square plus I3 square plus so on till IN square divided by N. So I square is equals to, so here, so here 0.24, 0.24 and RT will get cancelled. So the remaining will be I square is equals to I1 square plus I2 square plus I3 square plus IN square. So on till IN square divided by N. So the total IRMS is equals to under root of I1 square plus I2 square plus so on plus In square divided by N. So we will calculate through one problem. So here calculate the RMS and average values of a periodic voltages having the following values for equal time intervals changing sudden from one value to the next value. Okay. So that is it is given 0, 5, 10, 20, 50, 60, 50, 20, 10, 5, 0 and minus 5, minus 10 volts, etc. Likewise. The solution is here. The average value E will be calculated for half cycle. So average value for half cycle. So minus we should not consider because it is only half cycle. So here all positive half cycle values positive values have been given. So we have to consider only the positive values. So that is 0, 5, 10, 20, 50, 60, 20, 50, 20, 10 and 5. Here we have to take the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 values. So divided by 10. So 230 divided by 10 that is equals to 33 volts. So the average value of this positive half given is equals to 23 volts. So likewise, the RMS value of the above waveform is 0 square, 5 square, 10 square, 20 square, 50 square, 60 square, 50 square, 20 square, 10 square and 5 square divided by 10. So the RMS value equation also formula also we have seen the same formula we have to substitute. So we are taking only the positive half cycle. So here that is root of 965 which is equals to VRMS is equals to 31 volts. So in this session we have discussed about the definition of average value and the definition of RMS value and mid-ordinate method of calculating the average and RMS values. And we have solved very simple problems on the mid-ordinate method. And we will go for the quiz points. So here The RMS value is the steady quantity which produces the same dash effect as that of an alternating quantity, heating effect. Okay. The average value is the steady quantity which transfers the same dash that of the alternating quantity. It is charge. Okay, the same charge. So these are some of the frequently asked questions, the definitions and the explanation of mid-ordinate method. Okay. Um, so hope today's session is understood to you all. A very simple mid-ordinate method we have discussed, and we have applied the same mid-ordinate method considering some problems. So that how it has been applied to a problem. Um, so thank you for today's session. We will meet in the next session. Thank you so much.